Hi, this is review recording 1ABC, which accompanies the instructional recordings 1A, 1B, and 1C for Unit 2, Section 2.2 of Mathematics 2200. We'll work with trig ratios given a point on the terminal arm of an angle. We'll determine the sign using the cast rule of a given trigonometric ratio for each quadrant. And we'll be working with trigonometric ratios for our special angles. Example 1. Given the point P, negative 7, 4 is a point on the terminal arm of angle theta in standard position. What are the exact values of the three trigonometric functions for theta? So because it says exact, this is a non-calculator based problem. Negative 7, 4. We're told that point is on the terminal arm. So put a terminal arm up to there. And we rough in the other sides of the reference triangle. So this is negative 7, and this is 4. We have the x side and the y side of the triangle. Theta is in standard position, so we'll draw in the rotation starting from the positive x-axis. And of course, in here is our reference angle. Now, we don't need to find the reference angle to complete this problem. All we need to know is what is the r value. So by the Pythagorean theorem, negative 7 squared, make sure you square all of that negative 7 so it becomes positive when you square, plus 4 squared equals r squared. So it gives us 49 plus 16 equals r squared. That's 65. So our r value is the square root of 65. I had to move things a little bit here to make some room. R is root of 65. So we now mark that on our diagram. And sine theta is equal to the y value over the r value, 4 over root 65. So that eliminates C and D as possibilities and eliminates B. Let's make sure the rest are correct though here in A. X over r for cosine of theta, yes, negative 7 over root 65. And tan is 4 over negative 7, which, when you move the negative sign up to the top or the middle here, we have the correct answer. In this next one, a standard position angle, theta has the reference angle of 25 degrees. Tan theta is less than 0. That means it must be negative. And theta is between 180 degrees and 360 degrees. That's an important piece of information. So I make a set of axes here. I'll put in my cast rule. Now, the problem says tan theta must be negative. That means our terminal arm cannot be in quadrant 1 because tan is positive there. Tan is negative here. That's a possibility. Let's temporarily put that guy in there. And tan is positive here, so that's no good. And we could have an angle down in this quadrant. Both of those, remember, have a reference of 25. But there's a little bit of another catch to this problem. Our angle must be between 180 degrees and 360 degrees. So we cannot be in the second quadrant. Therefore, we eliminate this guy again, take that one out, and we are left with this angle. All we have to do is find its measure. Because it's in the fourth quadrant, the measure of the angle is 360. Subtract the reference, which gives us 335 degrees. D is the correct answer. In this last one, we're told that tan theta equals negative 1 over root 3, and we have to use diagrams involving a special triangle to find all possible measures of theta, first of all. For clarity, I'll break this up into two diagrams. Our tan value is negative, so we note that. Therefore, we could have a terminal arm in quadrant number 2. And remember, the tan of an angle is equal to the y value over the x value. So we will have a y value of 1 and an x value of root 3, keeping in mind which one is negative. Looks like the root 3 is the negative in this case. We think about our special 30, 60, 90 triangle. That has sides of 1, root 3, and 2, with the 30-degree angle across from the 1 and the 60 across from the root 3. So this must have a reference angle of 30 degrees. And obviously the hypotenuse here must be 2. We're looking for the measure of the angle from standard position. So in quadrant 2, our angle, theta, is equal to 180, subtract the reference. So it's 180 minus 30 degrees, which is 150 degrees. Our other possible quadrant where tan could be negative is in quadrant 4. And therefore we have a y side of 1 and x side of root 3. Keep in mind which one is negative. In this case it's the negative 1. We have our 2 down here. Our reference angle is 30. So now we can figure out the value of theta in that case is 360 minus the 30, which is 330 degrees. The last part of this problem is to find the cosine and the sine of each of those angles. The cosine of 150 degrees is negative root 3 over 2, the x value over the r value. And the sine value is 1 over 2, y over r rather. Meanwhile, cosine of 330 is root 3 over 2, the x value over the r value, and sine of 330 is negative a half. In all of these examples, we used a reference triangle, and we could use cast in examples 2 and 3 to help us locate the possible quadrants for terminal arms. And when you are working with a special reference angle of 30, 45, or 60, make sure you use the appropriate special triangle.